Chalo, without further ado, let's start and let me quickly add the MCQs we'll be doing today. Let's do this. Let's just do this. Party wala dance. Let's do this. Let's do this. Let's do this beautiful stuff. So, 2024 set for chapter number 2. Phosphorus forms a compound with hydrogen called phosphine and it's pH3. Now, the moment I look at pH3, I know phosphorus is in group 5. Isn't that true? And if it's in group 5, it has 5 electrons in its outermost shell. And if it's making 3 bonds with hydrogen, then it still has 2 electrons remaining as lone pair, right? So this is how pH3 would look like. It would look like this right here. That's H, that's H, that's H, and that's your beautiful lone pair. What would be the bond angle, guys? The bond angle, if it was tetrahedral, it'll be 109.5, but it's instead of one more bond, it's just a lone pair, so it's reduced to 107, right? We all know that because the lone pair pushes these bonds, right? So it's 107 degree, and next question, what is this shape called? This shape is called, because this is like a pyramid, this shape is called trigonal, because 3 bonds, trigonal pyramidal. So that's the shape for it. I'm not reading the complete question because I'm reading the complete question, but slowly and gradually giving you guys more and more details. You see, this compound can react with a hydrogen ion. Now, if you check this out, it's 1H, 1 plus ion, right? Now, hydrogen is 1, 1, right? If it's a 1 plus ion, that means it does not have any electron. If it was just a hydrogen atom, it would have 1 electron in its 1s orbital. But now it's a hydrogen ion, so it has no electron in its 1s orbital. This is an empty s orbital, and you have a lone pair. So how would they react? So that'll be a dative bond right here. So this is how it would look like, right? So this is P, that's the dative bond with hydrogen, and here you have the same things, tuck, tuck, and tuck. That's it, H, H, and H, and it would have a beautiful positive charge. Now, how has the shape changed? The shape has changed to tetrahedral. And what's the bond angle? The bond angle is 109.5. Right? Easy peasy, a lemon squeeze, and that's the dative bond right here, dative bond, right? And covalent bonds as well. And he's saying which type of interaction occurs between pH3 and H+. Now, you do not need to do all of this stuff. Automatically, you'd know it's a dative covalent bond, or also known as a coordinate covalent bond. There's no dipole forces, hydrogen bonding. No, it is between O and F bonded to a hydrogen atom, ionic bonding, pathetic. So if your concepts are clear, A-level examiner can give you things which are so easy that you will be like, what are these options even? Hi Taimur, what's up? How can you tell it's group 5? Hashim, I can tell it's group 5 because phosphorus is in group 5. Phosphorus is in group 5. It's already in group 5. You can check the periodic table out for it, right? That's how I can tell. I peeked at the periodic table. I didn't peek at it, but it's just it's inbuilt in my brain at this point. Next. The element tin exists in 2 forms, gray tin and white tin. Some properties of gray tin and white tin are shown. Okay. He's saying gray tin has this boiling point and white tin also has this boiling point. It's a pretty high boiling point. Won't you agree with me? High boiling point? It's pretty high boiling point, right? Pretty high. And if it has a high boiling point, there's a very high chance that it's a metallic lattice. There's a very high chance that it's a metallic lattice. There's also a very high chance, whatever. There's a very high chance that it's a covalent lattice, right? But which covalent lattice? A giant molecular lattice or a simple molecular lattice? That's the question I want to ask you guys. If it has a high boiling point, is it a giant, I'm just writing out the possibilities. So it's also possible it's a covalent lattice. Which one? Simple covalent lattice or giant covalent? Giant molecular. Obviously, there's a chance that it's giant molecular because giant molecular has a high melting point and a high boiling point, not simple, right? So it can be giant molecular lattice, and it can also be something. It will also be ionic lattice, right? Because all 3 would have high boiling points, high melting points, right? Usually, obviously, and obviously your simple molecular structures are not going to be a part of it. So whatever option that you have containing simple molecular, we can automatically cross that out. So it's not just covalent lattice, it should be giant covalent lattice if it were covalent, right? This is just our assumption. It can be this, it can be his, it can also be his. Now he's giving us further details. He's saying None electrical conductivity. There's no electrical conductivity in solid or in liquid. Liquid means what? Molten. So if it's not conducting electricity in solid state, it cannot be metallic. Everybody agrees with me. Can it be metallic? No, because metals conduct electricity in solid state. Can it be ionic? No, sir. It can't be ionic because ionic compounds conduct electricity in liquid state because there are mobile ions. Liquid is basically molten state. So it can't be metallic, can't be ionic. Which option is left? He's also giving you guys further reasoning to it. It's brittle. It's not malleable. It's brittle. Again, telling you it's not metal. It's not metal, please. So what does that indicate? That indicates all these three combined indicate that it must be a giant molecular lattice. That's it. Pretty logical, right? It's deduction. It should be giant molecular. There's no other option, because you've eliminated all the possibilities for me. So it must be a giant molecular lattice. Now, he's saying, let's look at white tin. White tin is basically, again, has a high boiling point, so can be either this or this or this. He's saying it's a good in solid and in liquid. What does that eliminate for you? If it's good in solid, that means it must be metallic. It can be metallic, right? It can be definitely metallic. Because why can't it be ionic? Because ionic, we can cancel this out because ionic compounds conduct electricity in molten state and in aqueous state, not in solid state. So in solid state, if it's conducting electricity, it's most definitely metallic, right? And it's also giving you guys, and you guys can also think, sir, but okay, you also have graphite, don't you? Graphite is a giant covalent lattice or a giant molecular structure. It can also conduct electricity, right? But is graphite malleable? No. Malleability is the property of what? Of metals, further indicating the fact that it must be a metal. So you effectively are going from, if you check out the differences between gray tin and white tin, gray tin is a giant molecular lattice and white tin is effectively a metallic lattice. Now you're saying, which structural change might take place when gray tin changes to white tin? Which structural change? You would go from a giant molecular lattice to a metallic lattice, right here, metallic lattice. So giant molecular lattice or giant covalent, not giant ionic. It's not ionic, right? We already figured that out. It's not ionic. Giant covalent to giant metallic, not ionic, sir. Not ionic, right? Because ionic doesn't conduct in solid. Done. B is the correct option. This is how easy A-level MCQs are, I swear. Which solid has a simple molecular lattice? Simple molecular lattice, covalent bonding, right? But it must not be giant, right? So calcium fluoride is CaF2. This is ionic. So this is pretty logical. Nickel is a metal. This must be metallic. Done. Silicon 4 oxide. It is SiO2. It is what? Giant molecular lattice. It's a molecular lattice, but giant. Sulfur is S8. And it is, in fact, a simple molecular lattice. Why is he calling it a lattice? Because it's a regular arrangement. Sir, how do you know it's a regular arrangement? How do you know it's a regular arrangement? Lattice just means regular arrangement. How do I know that? Because S8 is a solid. And we know solids have a lattice. It's a regular arrangement, right? So sulfur exists in the form of S8. We've already studied that in chapter 4. So D is, in fact, the correct option. Next. This is how easy these MCQs are. I swear to God, I'm not joking. An ion contains one nitrogen, two hydrogen atoms. It has this type of bond and the bond angle is 105 degrees Celsius or 104.5. 104.5. What does that tell me? Nitrogen is bonded to two hydrogens right here. Right? That's what he's telling me. And the bond angle is 105 degrees Celsius, or you could also tell yourself 104.5, largely the same thing. And what does that indicate to you guys? If you check nitrogen out, nitrogen is in group 5. If it's in group 5, it is sharing one electron here. It is sharing one electron with this hydrogen right here. So how many electrons should remain? There should be 3 electrons left, right? So I can write these beautiful 3 electrons. Now these 3 electrons left here is not going to give me a bond angle of 104.5 or 105. What else do you need? Sir, you've seen H2O in a lot of detail. Why is H2O 104.5? Why is H2O 104.5? Because it has 2 lone pairs. So what would happen is that an electron should come from the outside and come right here, and this would make this NH2 have a negative charge as well, right? Now the bond angle we know is going to be 104.5. You have 2 lone pairs right here and the bond angle is 104.5, right? So you're seeing number of lone pairs around the N in iron. How many lone pairs do you have? You have not 1, but you have 2. Overall charge, it's not +1. It is a -1. So not +1, -1. Now some of you might think, sir, what if there may be a lot of confusion, so I can also clear that out. Sir, what if, sir, instead of having the third electron, nitrogen were to lose this third electron? What if nitrogen were to lose this third electron and you'd have something like this, and then you would have a +1 charge, right? Then I would say, hey, it has one lone pair and +1 charge, right? You guys could argue with me, sir, what if this was the case? This is also possible. Instead of taking an electron from the outside, it would lose this one and you'd just have one lone pair and +1 charge, so the option would be A. But please understand that if it were this case, for this, what would be the bond angle? See, if this lone pair did not exist, it would be 120. It now exists, therefore it's going to be squeezed a little, it's 117. So this would not be 105, it would be 117. That's why I say don't rote learn things. Let's suppose the examiner wrote it has approximately a bond angle of 117. That would mean what? That would mean that this is not possible. It has actually lost an electron, and then A would be the correct option. That's how easy things are. That's literally, if conceptual clarity is there, everything is a piece of cake. Why does ICL have a higher boiling point than Br2? ICL has a higher boiling point than Br2. Please don't just rush into the options. Don't rush into the options. Can I first check out what boiling point depends on? Boiling point depends on intermolecular force of attraction. This should be your thought process. And intermolecular force of attraction are three types. It can either be ID-ID, PD-PD, or hydrogen bonding. There's no name shame pain of hydrogen bonding. There's no hydrogen bonding here, so it's either ID-ID or PD-PD. Okay, for ID-ID, the boiling point is influenced by what? The number of electrons. Can you guys tell me the number of electrons here? The total number of electrons here. Can you go to the periodic table, check out how many protons bromine has? That'll be the number of electrons it also has. So you guys check that out, please, for me. Please, periodic table prints should be in front of you at all times. Without the periodic table, you guys are nothing. Even I am nothing without the periodic table. Bromine has 35 protons, so it must also have 35 electrons. Therefore, that's what? 70. So you have 70 electrons in total here. And how many electrons do you have here for ICL? What's I? Please tell me the number of electrons for I. I think is 53, if I'm not wrong. And chlorine has 17 protons, therefore 17 electrons as well. So what's going to be this? This is also going to be 70. Can you guys tell me, is the ID-ID attraction going to be different for these two? Broadly speaking, is the ID-ID electron going to be different for the two? Aisha, it's not 88. I just saw it in the nick of time. The smaller number is the proton number. The larger number is the mass number, the nucleon number, because it also takes into account the number of neutrons. Please, no, Aisha, these mistakes, I know you made a mistake, it's fine, but these mistakes will cost you a lot in AS level. It's merciless. Okay, my question to you guys is that can I say that ICL has a higher boiling point than Br2 because it has more ID-ID interactions? Can I say that? Please help me out. You can use the mic, guys. You guys are grown-ups. I like chit-chatting with you guys. Yes, you guys can use the mic. Just like you guys can talk to Janu, Manu, Shona, Tota. No, I'm sorry. Allah na kare. Khair. Tell me, can I say this? Please, bole. Tell me, please, this is not an MCQ class. I have to teach the proper class after this. I have to quickly do 20 MCQs with you guys. So can I say that ICL has a higher boiling point than Br2 because it has more ID-ID interactions? Can I say this? Yes, Aisha is absolutely right, sir. You cannot say that because they have the same number of electrons and ID-ID interactions are influenced by the electrons. So you can't say that. Then why would ICL have higher boiling point? Well, hydrogen bonding is not there. ID-ID interactions are the same. Then what's the other thing that's left? Sir, the last thing that is left is what? Sir, it has permanent dipoles. There's a difference between the electronegativity. So it also has PD-PD. ICL also has PD-PD interactions, right? So that's the idea. Now he's saying because of the difference between bond energies of the covalent bond within ICL and Br2. Now some of you might be inclined to circle A out. That's why I say read all the options. A is wrong. Why is A wrong? I also have to tell you the why. If I'm saying it's wrong, it's wrong. The reason is he's saying the difference in bond energies. He's saying, hey, you require more energy to break this bond than you require to break this bond, right? He's saying you require more energy to break this bond than you require more energy to break this bond, right? It might be true. It might be true. I don't know. Maybe you do require more energy to break this bond than this bond. But does the boiling point depend on these covalent bond or does it depend on intermolecular forces of attraction? He's saying the bond energies of the covalent bonds within ICL and Br2. No. We don't look at within. For boiling and melting, we look at the intermolecular force of attraction. We don't look at the covalent bonds, sir. This is the typical mistake which O-level students used to make, right? So that's wrong. No, not within. Because of the difference in the polar nature, absolutely. this is polar and this is non-polar. Yes, sir. So this also has PDPD. So yes, because of the difference in the number of electrons contained within ICl and Br2. No bueno, examiner. You think you can fool us? They have the same number of electrons. I've already calculated it. Because of the difference in the relative molecular mass. Are you dumb, examiner? Does the boiling point depend on the relative molecular mass? Like what the hell? No, it doesn't, right? So next. So therefore, which answer is correct? Obviously, B is the correct answer. Which statement about the properties associated with the different types of bonding is correct? Please, A levels is a piece of cake. I say this over and over again. And teachers, they just can't read English. To much extent, you'll see teachers who just are going to get confused themselves because they can't read English. I want you guys to develop that attitude of reading each and every word of the examiner, what the examiner is writing. The examiner can only play with you in AS level MCQs in wordings. It is far easy compared to theory, I swear. And you have studied the theory. The theory is more fun and it's more difficult to grasp. You once grasp it, you practice it, you recall it, you're done. You're good to go. Right? You're good to go. But the MCQs are just straight up answers. See, which statement about the properties associated with different bonding involved is correct? Any covalent compound that contains both oxygen and hydrogen, okay, in its molecule forms hydrogen bonds. Yes, and a lot of students might be inclined towards circling A out. And the answer is no. See, try to read English. Please try to read English. Why is A wrong? Please, whoever tells me, 100 rupees. I'm going to pause the recording. Whoever tells me why A is wrong, I'll give them 100 rupees. Yes. Aisha is saying compound and molecule. No, it doesn't have anything to do with that. Contains a compound can also be a molecule. Like carbon dioxide is a compound and it's also a molecule. That's not the reason. Yeah. So, what's the English? Hydrogen bonds are formed between two molecules. Now, it can be formed between two molecules, but if it contains hydrogen and oxygen, if like a molecule contains hydrogen and oxygen, it'll form a hydrogen bond with the other molecule as well, right? There are three discrepancies with this statement that I can trigger out, right? What three discrepancies are in this statement? That's why conceptual clarity is so important. And my advice to you guys is always read all the options and then, select between the ones which you see are the closest, right? Before I give you the irrelevance of A, let me also read all the other options. So B says ionic bonds and covalent bonds cannot both occur in the same compound. Absolute BS. This is not possible. Like, there are so many examples you've studied throughout your O levels. Ammonium chloride, NH4 has covalent bonding, and ammonium ion and chloride ion has ionic bonding. Sodium carbonate, all the polyatomic ions. Sodium carbonate, sir, this is ionic bonding between the sodium ion and the carbonate ion, but between the carbons and oxygens right here, you have what? Covalent bonding. This is in fact absolute BS. Sodium ion being bonded to the sulfate ion. You have ionic bonding, Na2SO4, ionic bonding as well as covalent bonding right here. So in the same compound, you could have ionic bonds and covalent bonds. So B is absolutely incorrect. Ionic compounds differ from metals in that ionic compounds do not conduct electricity in solid state. Oh, this is absolutely correct. I know that ionic compounds don't conduct electricity in the solid state. They conduct in molten and aqueous, and metals do conduct electricity in the solid state. So C should be the correct option. But read everything, and the teacher's job is to not tell you which is the correct option. The teacher's job is always to tell you why are all the other options incorrect. You can also check the marking scheme out for it to just check out कि oh ये सही है but ठीक है. No. We're going to come back to A. What's the problem with A? The only covalent compounds with high melting points are those in which hydrogen bonds occur. SiO2 is a covalent compound and it has a high melting point. There's no and a high boiling point, high melting point, because there's no hydrogen bonds here, but it's a giant molecular lattice. So that's also absolutely incorrect. Now, why is A incorrect? What's the problem with A? Right? Absolutely, Manur has got the hang of it. Manur is saying, sir, there's a fundamental error. The examiner is saying any covalent compound that contains both oxygen and hydrogen in its molecules form hydrogen bonds. Now, you might be inclined to circle this, but the problem with this is, has he said that the hydrogen is bonded to O? He's just saying it contains it. We do not care if hydrogens and oxygen are contained within a molecule. That is not the definition of hydrogen bonding. That's not how hydrogen bonding occurs. Hydrogen bonding can only take place if hydrogen is bonded to the O, N or F in that particular molecule, directly bonded to it. Right? That's one of the fundamental errors in this statement. Do you want me to take out more fundamental errors? So Manur is absolutely correct. Manur is saying, sir, he's not mentioning, he's just saying it contains it. He's just saying it contains oxygen and hydrogen. I'll give you a billion examples where you'll have oxygen and hydrogen, but it won't be, it would not have hydrogen bonds. For example, this fella right here, whatever this fella is, I don't give a shit, but this fella right here, is there any hydrogen bond? Is there any hydrogen bond? Absolutely no. There's O, there's H, but is the O directly bonded to the H? No, absolutely not. No hydrogen bonds. So please understand, don't rote learn things. Don't rote learn stuff, right? So A is absolutely incorrect. And the other fundamental error with it is he's not mentioned. He's saying it just contains it. Well, let's suppose he had also written this part. How do I know that there's a lone pair on the O? Because we know that hydrogen bonding takes place if a hydrogen is directly bonded to the O, and on the adjacent molecules, oxygen, nitrogen, or fluorine, you have a lone pair. He's not even mentioned that. So one more, discrepancy that you could figure out. I'll give you a third discrepancy. It must be polar. We know hydrogen bonding takes place if it's polar. So must be polar. So if there was no statement of C, let's suppose there was no C, then majburan, then it would be my what's it called? Majburi. What's majburi called in English, please? It would be my what's it called? I need the English word for it because it's gonna go on to YouTube. No, it's our duty? No, not duty. But if the C option was not there, then out of a lot of contemplation, I'd go for A, because I'd figure out that, oh, it's implied, this is also implied, that's also implied, that's also implied. Then I'd go for A. But between C and A, I clearly see that C is bilkul tich tally. Yes. Out of compromise, thank you. So I'd just compromise and improvise and just go for A. If C option was not there, anything like C, if this was not a clear option, let's suppose you said ionic compounds differ from metals because ionic compounds conduct in solid state, then I would cross out C because it's blatantly false. And then I'd just assume that the examiner is saying that all of these are implicit in this, implied in this. So then that's pretty simple. The diagram shows the structural formula of a hydrocarbon molecule Q. How many carbon atoms in the molecule Q are sp2 hybridized? How do you know sp2 hybridization? The electron geometry should be trigonal planar. The electron geometry should be trigonal planar. Let's look at each carbon. So this carbon has an electron geometry of trigonal planar. See, 3 electron densities. Boop, 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 boop. So trigonal planar, 120. Let's look at this carbon right here. 1 electron density, 2, 3. You don't look at the number of the bonds. You look at the electron density. 1 here, 1 here, 1 here. That's trigonal planar. 3, right? So that's also trigonal planar. Don't be confused by the structural formula. He's just given you guys the structural formulas or the displayed formulas. He's not giving you guys the shapes. He has not given you guys the 3D shapes. You have to just imagine them. Let's move on to the next carbon. Let's look at this carbon. This carbon has 4 electron densities right here. So it's tetrahedral. 1, 2, 3, 4. 4 electron densities. Tetrahedral. So this is not the option. I can cross this out. Similarly, this carbon has what? 1, 2, 3, 4. 4 electron density. I can cross this out. Look at this carbon. This carbon has 1 electron density, 2, and 3. This double bond is considered as a single electron density, right? So 1, 2, 3. We've learned electron geometry in the last classes. So 3, that's trigonal planar, and absolutely, this is also a good fella. Similarly here, it just has 1, 2, 2 electron densities, which mean what? It's linear. So this one is linear. This one is tetrahedral. This one is tetrahedral. Doodh ka doodh, pani ka pani. Similarly, this one right here, 1 electron density, 2, 3. So you should be very quick at this. I'm just slowly going over it because, it's your first time probably. That's why. So that's also, trigonal planar sp2. See, 1 electron density, 2, 3, that's it. Or because there are no lone pairs, you could have also said, hey, there's the sigma bond right here, sigma bond, sigma bond, sigma bond, and 1 pi bond. So the S and 1p and 2p, S and 2p's would combine to give you sp2, and there's 1 pi bond which needs an unhybridized p orbital, right? So you could also use that analogy. I've taught you guys multiple ways of thinking about this, right? Similarly, if I look at this carbon, 3 bonds here, 1 bond here, so it's like this electron density in that, so that's linear. This is also sp2. Linear is sp2. Linear is sp. My bad. What was I saying? Linear is sp, and sp3 is tetrahedral. sp2 is trigonal planar, right? Similarly, if you look at this carbon right here, it's also linear, 3 and 3. One electron density here, one here, 180, that's linear, right? So that's cross, cross, cross. And what about this? This is again tetrahedral. So, that's what a teacher should do. अपनी तारीफें मैं नहीं करता, बट मजबूरन करनी पड़ती है, मतलब इतना साफ साफ कौन बताता है. So how many do you have? B, 4. That's it. Hashim, have you watched the lectures for electron geometry hybridization? If you've watched them, then it's pretty simple, Hashim. If you've watched those videos, it's pretty simple. This is one electron domain, that's the second, that's the third. It's sp2. It's trigonal planar. He's not shown you this. He's not shown you the actual shape for it. He's just given you a structure for it. We've done a lot of examples like this in class. So if you've taken them, you could check out the class examples. I've done it at the end. And we'll come back to it at the end if you want, if you have other questions. When solid aluminum chloride is heated, Al2Cl6 is formed. Okay, and we know that's simple molecular. After studying chapter 4, we know it's simple molecular. Okay, now I'm saying which bonding is present in Al2Cl6. How does it look? Cl, Cl, a Cl, and there's a dative bond right here. This is Al, there's a dative bond right here, and you guys have seen this fella. It's AlCl3 this, AlCl3 this, but this lone pair forms a dative bond with Al, and this lone pair forms a dative bond right here. So, which type of bonding is present? You have covalent bonding and you have coordinate covalent bonding, which is dative bond, right? Covalent and dative. This is the dative bit, and that's the covalent bit. So you have covalent bonding and dative bonding. No ionic bonding, no. All right, so not just covalent only, it is covalent and dative. That's how easy it is. The structure for sulfur dioxide is shown. Which shape is this? So it's S having two O's, S being bonded to two O's, and there's a lone pair. So it's what? It's bent, literally. Bent. Bent is also known as V-shaped, angular, or non-linear. Yeah. So it's bent, literally. There's no. This is my central atom. You look at the central atom and the lone pairs on the central atom. You just push it. It's not linear. It's not linear. It can't be linear. There's a lone pair. If there's a lone pair, it can never be linear. So not linear, not pyramidal. How can it be pyramidal? There's no pyramid, right? It's not tetrahedral. It's non-linear. It's bent. That's it, guys. Next. The graph shows the boiling point of hydrogen compounds in group 7 without even looking at anything. Have I not shown you these graphs? That's why graphs are so important. Have I not shown you these graphs? What explains this dip? What explains this dip right here? I've shown you these graphs. What explains this dip between H2O and other group 16 hydrides? What is this dip? How do you explain this dip? It's because of hydrogen bonding. Remember all the story of H2O. I've told the entire story of H2O, how it has the boiling point of 100 and all the others have. And if H2O did not have hydrogen bonding, we'll all be dead. Right? We won't even exist because our body is almost, I think, 70% water or whatever. The entire story. Remember that. So which statement correctly explain why water does not fit? It does not fit because of hydrogen bonding. Which story? Let's see. There are fewer electrons, blah, blah, BS. There are strong hydrogen bonds in water and not in any other compound. Yes, it's not present in the other compounds, right? In H2S, in H2SE, in H2TE. No. Why? Because hydrogen bonding exists if oxygen is directly bonded to if hydrogen is directly bonded to O, N or F, three of the most electronegative elements of the face of planet Earth. So B is correct. All the others are just BS. The covalent bonds in water, we don't look at the covalent bonds for boiling point. The water molecules are smaller. No, pathetic. This is not so have stronger van der Waals. Van der Waals do not depend on smaller or what. It depends on the number of electrons. Even the statement is incorrect. What is the bond angle between the ammonium ion? Ammonium ion is NH4 1 plus ion. What's the bond angle? What's the bond angle, sir? It's pretty simple. Ammonia gas would have been, right, this. It would have been NH3. That's ammonia gas. And it has a lone pair. And how does the ammonium ion form? Well, it just forms a dative bond with the hydrogen ion. So there's this dative bond right here. We've drawn it in chapter number 2 multiple times. What's the bond angle? What's the shape? It's tetrahedral. Tetrahedral, what's the bond angle? 109.5. That's it. Pretty like there's no, I'm not even using my brain at this point. The diagram shows the structure of X, which is correct. Now, sigma bonds in X. Now, before you've not seen structures like this. Let me even simplify it for you, because you'll learn more of this in organic chemistry. But these dots, these nodes are actually carbons. So these are carbons, slowly and gradually also getting a taste of organic chemistry. So these nodes are actually carbons. Now, can you guys tell me how many sigma bonds are there in X? I've even simplified it for you. How many sigma bonds are there in S? Now, a lot of you are going to say, sir, 1, 2, 3, 4, 5. Sir, I think 4, 1, 2, 3, 4, or 5. There's no 5, so should I go for 4? Absolutely BS. Absolutely incorrect. Because see, that's what the examiner will do. Like, I'm not even joking. It's so easy. What has the examiner done? The examiner has shown C combined with N. Open this up. Open this up for yourself. C bonded to N is what? C triple bonded to N right here. It's a triple bond. Carbon is in group 4. It has made 1 bond here. It will make 3 bonds with N. N needs to make 3 bonds to have a stable electronic. Now, check out the sigma bonds. So, in a triple bond, the first bond is the sigma bond. The other two are pi. So, pi and pi. So, 2 pi here and 1 pi here. So, you have how many pi's? You have 3 pi's. How many sigmas do you have? So, the blue ones are the sigmas. So, 1 sigma, 2 sigma, 3 sigma, sigma 4, sigma 5, sigma 6. So, 6 sigma bonds and 3 pi bonds. And he's saying type of hybridization of the carbon atoms in X. So how are they hybridized? See, this is carbon. It has how many electrons? What's the electron geometry? One electron group here, one here, one here. Electron domain here, here, here. So 3 electron domains. It's what? Trigonal planar. Trigonal planar is what? sp2. And similarly, this is what? sp2, trigonal planar. But if you look at this fella right here, there are just 2 electron domains. One here, one here. This is linear. Although I might not have shown it linearly, and nor will the examiner, but this is linear. And linear is what? sp. There's no sp3 because there's no tetrahedral shape, is there? So it's sp2 and sp. So 6 sp2 and sp. C is the correct option. There's no sp3. For sp3 to exist, the electron geometry must have been tetrahedral. Right? There's no tetrahedral. Next, which shape is correctly predicted by the VSEPR theory? Now, it's like it's a walk in the park. Number of bonded electron pairs. You have 2 pairs and 2 lone pairs. If you have 2 bonded electron pairs and 2 lone pairs, like X, 2 bonds, 2 bonded electron pairs. This is what he means by bonding electron pairs. This is bonded and that's bonded, right? So I'll just imagine it. 2 here, and he's saying it has 2 lone pairs. What would be the shape for it? For the life of it, can it be linear? It's not linear. What's the shape? It's bent. And you've seen something like this. It's like H2O. You've seen something like this, H2O. It has 2 lone pairs and 2 bonding pairs. So it's bent. And the angle is what? If the examiner were to ask us about the angle, it should be 104.5 or 105, right? So for the life of you, it's not linear. Now I think again, 2 bonding pairs and 2 electron pairs is tetrahedral. You dumbass. It's not sorry guys. It's not tetrahedral. What is it? It's what? It's bent. It's V-shaped. What in the hell, examiner? Like, make some difficult MCQ so we can enjoy it. I think 3 bonded pairs, bonded electron pairs, and 1 lone pair. So let's use it. So it should be 3 pairs like this, tuck, tuck, tuck. And he's saying there's 1 lone pair. So let's call this whatever. Let's call this hydrogen, whatever. It doesn't really make a difference. Have you seen this before? It's like ammonia. Ammonia gas. That's how ammonia gas looks like, right? So 1 lone pair and 3 bonding pairs. What should be the shape for it? It's what? It's pyramidal right here, and it's trigonal pyramidal. You could write pyramidal or trigonal pyramidal. And what's the bond angle, guys? What's the bond angle? Well, if it was tetrahedral, it'll be 109.5, but now it has been reduced to 107. So that's the bond angle, 107, and it is pyramidal. Absolutely, C is correct. Let's look at this D stuff. It can never be planar if there's lone pair. So without even looking at it, I could eliminate D out. But if you want to look at it, 3 electron pairs and 1 lone pair. Is this trigonal planar? Trigonal planar should have no lone pairs. It should be just 3 bonds, right? It's just like AlCl3 mein. Right, so D is wrong. Which species does the underlined atom, in which species does the underlined atom have an incomplete outer shell? Incomplete means either fewer than the octet or more, not more, you could also think more, but incomplete is like fewer than the octet. I think that's the better, interpretation of incomplete. It's lacking 8 electrons, right? BF3 is the correct option. You've done so much practice that you should directly go for A. And Aisha is absolutely right. Aisha is saying it does not fulfill the octet rule, and I can even prove it to you. Boron is in group 3. Now, if you were not me, then you would probably do your working. So you'd say, hey, boron is in group 3. If boron is bonded to 3 Fs, which means each boron is giving the boron is given 1 electron here, 1 here, 1 here. Now, how many electrons does it have in total? Boron 2, 4, 6. It lacks 2 electrons. That's why, us accountants, we normally put a tick like this. Hashim would know. What about the other options? Sir, please explain those. I will do most gladly. See, carbon is in group 4. It has made 3 bonds with hydrogen. So shared 1 electron there, 1 electron here, 1 electron with the other hydrogen, and in total now you have 6 electrons in the bonding electrons, right? So you have 6 bonding electrons because hydrogen is also sharing 1. So carbon has shared 3 electrons and hydrogen has shared 3 electrons. So carbon's outermost now is total 6, right? But it also has 1 electron left in its outermost shell. So 6 plus 1, that's 7. Because carbon has only made 3 bonds, 3 hydrogen, 3 bonds. And there's a 1 minus charge. So there's 1 more electron that has come from the outside. So just add 1 more to it. That is what? 8 electrons. So it has fulfilled the octet rule. Similarly, F2O. F2O is what? O bonded to 2 Fs. O was in group 6. It should have 2 lone pairs right here because it has shared 1 electron here and 1 here. So how many total electrons does O have now? 2, 4, 6, 8. It's also happy. C is wrong. H3O plus. H3O plus looks like what? It's hydrogen, and O, the other H is basically a dative bond right here with a hydrogen ion, right? So this is how it would look. The plus is overall then. And if you check this out, you guys can figure out the number of electrons of O. See, O was in group 6, so it shared 1 electron here, 1 here, and had 2 lone pairs. Out of that, 1 lone pair has been used in the dative bond, right? So how many electrons does O have? 2, 4, 6, 8. The bonding is like a Venn diagram, isn't it? So these electrons which are involved in bonding also are counted as part of O's electrons, right? That's why bonding takes place. So these are also what? 8. So that's a piece of cake, a walk in the park again. Consider these 4 compounds. In which order of increasing, what is the order of increasing boiling point of these compounds? Lowest first. Okay. So lowest first and the highest later on. Out of these 4, which one is the highest? Just by looking at this, I can literally, I can spy with my little eyes that one of this would have the highest boiling point because of a reason. One of this would have the highest boiling point just by even looking at it with my naked eyes. The OH bit, this bit, because this would result in hydrogen bonding. O is directly bonded to H. And so if you take multiple molecules of this, it will be hydrogen bonding right here, right? So 2 is going to have the highest boiling point. So therefore, C and A are incorrect. Now, if I look at B and D, I just have to figure out whether 1 is the lowest or 4 is the lowest. If you look at 1 and 4, the only difference is this one is, this one is unbranched. This is unbranched. And this is branched. The above one is branched. It's shorter. It's branched. Now, we know that unbranched has a higher surface area. We've studied this in chapter number 2. Unbranched has higher surface area, and if it has higher surface area, there'll be more ID-ID interactions. Whereas branched does not have a higher surface area and then fewer ID-ID interactions. This has more ID interactions, therefore it'll have a higher boiling point compared to 1, right? So 1 would have the lowest boiling point, not 4. With 1 and 4, 1 should have the lowest boiling point. So therefore B is the correct option. Guys, is it easy or no? Is it easy or no? Please help me out here. Help me help you, girl. What you wanna do? No, I ain't no Scooby-Doo. Help me help you. It should be a walk in the park. I'm not joking. It should be. If your concepts are clear, I have not done these MCQs before. I gave my A-level back in the day. I'm doing these MCQs with you guys for the first time. And that's the reason why, these years are written on it. You could even track back and check whether I've done it correctly or incorrectly. But I'm so confident in my answers, in my concepts, that I know it's correct. I don't even have to look at the marking scheme. Silly mistake ho jaye, wo alag baat hai, but I don't. Because, sir, very easy. Chem is the easiest subject right now. Vanya, I'm happy. I'm glad. See, you've worked on your concept. That's why you see that for you it's the easiest subject. Because concepts are important. Those who have not watched every single video are going to suffer in the longer run. Remember this, there's still a lot of time. Easier than paper 2. Hamza, I told you, MCQs are literally easier than theory. Literally. Theory is proper understanding of stuff. There are almost 99% of the teachers say that MCQs are difficult. Almost 99% of the teachers say MCQs are difficult. Do you know what I say? I say no. I say the theoretical aspect is difficult. Theory is difficult. Which theory am I talking about? Am I talking about exam theory? No. I'm talking about conceptual theory. Grasping that conceptual theory. And you guys can give my video solutions to your teachers who say MCQs are difficult. Literally. I'll upload this onto YouTube. You could share it with your friends later on. Arsenic forms a compound. Now see, arsenic, I don't know what the hell arsenic is. So I'll just look into my periodic table because I swear, like, I've not learned these answers or whatever. So arsenic is right here. I can see it. It's in group 5 or 15. And he's saying selenium, something about selenium. Selenium is in group 16. I automatically, okay. Arsenic is in group 15 or group 5 and selenium is in group 6, right? So arsenic has 5 electrons in its outermost shell and selenium has 6. Okay, good stuff. I don't care. Fine. I now know what they are and where they are placed. In this compound, the arsenic atom has no lone pairs. He's saying it forms a compound with fluorine. Okay. Oh, wow. Arsenic would have no lone pairs, which means what? Come on, Shaba. Which means what? Shaba. What does this mean? This means that all the electrons would be involved in bonding. Pretty much logical, right? If there are no lone pairs, then all the electrons would be involved in bonding. But fluorine can only make a single bond. So what do you think? How many fluorines would arsenic be bonded to? How many fluorines would arsenic be bonding to if there's no lone pair and there are even no dative bonds? He's even further clarified it. No dative bonds, no lone pairs. It's not like fluorine has an empty orbital. No. He's saying, no. Fluorine will have one electron in its outermost shell. You can make bonds on your own. No dative bond, no lone pairs, whatever. So how many bonds would arsenic make? It'll probably make what? 5 bonds. It'll make 5 bonds. With what? With 5 Fs. It'll basically bond to 5 Fs. And how would that look for you? It would look like this. Arsenic is As, if I'm not wrong. Yes. As, right? So how would that look? 5 bonds. This is F and F. We know how to draw it, right? F and F. And the base would be trigonal, planar, right? So the base is what? Trigonal planar. And this is F and F right here. So what are the bond angles? What is this called? What is this called? Since the base is trigonal planar, that's good. It's trigonal base. And this is also a pyramid. That's also a pyramid. So it's called trigonal bipyramidal. Trigonal bipyramidal. 2 pyramids, right? And what's the bond angles, guys? What are the bond angles? The bond angles are 180 between F and F. Between F and this bond, that's 90 bond angles. And in this base right here, in the trigonal planar base, these are bond angles of 120. So if 90, 120, 180. Good stuff. It's all chapter 2. All chapter 2. 90 and 120, Aisha, but also 180, right? Between the F and the F, the F and F bond. I told you the examiner normally does not mention it even in the books, but you should know that this is 180, right? Khair. Selenium also forms a compound with fluorine. Now selenium is in group 6. It has 6 electrons in its outermost shell. He's saying in this compound, selenium atom has no lone pair of electrons and no dative bond. Again, if it has no lone pairs and no dative bonds, what does that mean? That means it has bonded to 6 Fs. So what do? How do we draw it? We first draw this linear bond, FF, 4 more bonds, which should be square based. So this is the square based right here. Tuck. You know, this, tuck, and tuck. That's the square. But we know that it's not called square based bipyramidal, just like Sir Suleiman would want it. They're called octahedral because it looks like an octahedron. So it's octahedral shape, right? And what are the bond angles? In octahedral, all the bond angles are 90. They're all 90 because of the square base. And this F and F is 180. So 180 and 90. Now let's move on to the question, because the main reason is not just to do the question, it's also to revise your concepts. So now let's read the question. He's saying, so we know this one is octahedral, all bond angles 90 and one bond angle 180, right? And this has 90, 120 and 180. In which compounds are there are 2 different bond angles? In which compounds are there 2 different bond angles? In both. You have 90 here and 180 here. And you have 90, 120 and 180. So in both, there are different bond angles, right? In this question, 180 should be ignored. The examiner knows that there are teachers like Sir Suleiman who teach students proper concepts. They go outside the book. So we have to tell them that in this, ignore 180. So if I ignore 180, then you only have 1 bond angle, not 2. And here you have 2. So in arsenic, you would have 2 bond angles. And arsenic fluoride would have 2 bond angles. Selenium fluoride would just be 90. That's how easy these MCQs are. See? A walk in the park. This should be my famous dialogue. A walk in the park. Sir, please pizza khila de. If you want pizza, I want you guys to do something. If you actually want pizza, go to school tomorrow, make a video, like a vlog type video, flip the camera and, have a group of your friends stand behind you, or preferably the entire class behind you, and say, carboxyl chem, and everybody says, on top, carboxyl chem, on top, carboxyl. Say it 3 times with the most noise. The class that will make the most noise, I'll pay for their entire pizza. So, पूरे क्लास का पिज्जा मेरे पे. पिज्जा क्या है, 10-15 हज़ार रुपए होंगे, कितने होंगे? I'll pay for that. I don't care. I'll pay for your pizza. But don't do it with random kids. They banned phones in my school. How? In AS level, phones are allowed, aren't they not? That's crazy. So I think, Fatma, you're already disqualified. You can do it somewhere outside the school classroom with your friends. Just go like, carboxyl chem on top. Yes, carboxyl chem on top. If you want pizza, that's what you have to do. That's crazy, man. I love this shit. I love what I do, yeah. I love what I do. Okay, next question. June 24, 13. And you guys can send it. Those who are watching this on YouTube, you guys can send it to me on +92 333 5694 666. So whenever you guys have short funds, I can always pay for your entire class pizza. You just have to gather around like 10-15 students and just go like, carboxyl chem on top, carboxyl chem on top. Hashim, I'm not running back. I'm not turning back. Done. Neither say pizza done. But 10-15 students, just go carboxyl chem on top. Or if your class is larger than that, that's awesome. Okay, a structure of borazole is shown. Borazole. I don't know what borazole is, to be very honest. I'm not a biologist, but it looks like a good molecule. Which shape of borazole? What is the shape of the borazole of what shape is borazole, and how many pi electrons are there in the structure? How many pi electrons are there? So 1, 2, 3. So there are 3 pi bonds. And a lot of you, once you identify 3 pi bonds, because in a double bond, the first bond is sigma and the other one is the side-on overlap or the sideways overlap or the lateral overlap or whatever, right? So the first bond is sigma, pi, right? In the double bond, in a triple bond, first bond is sigma and the other 2 are pi's, right? So 3 bonds, right? And a lot of you would go for what? 3 and 3. What's wrong with 3 and 3? He's not asking you about the pi bonds. He's saying the number of pi electrons. So if there are 3 pi bonds, each bond has 2 electrons. So 3 times 2. 6 pi electrons. See, these are the things in which the examiner can fool you. The only things the examiner can fool you with is the English, literally. So there are 3 pi bonds, and in each pi bond there are 2 electrons. So how many electrons, pi electrons, not bonds, pi electrons are there? 6. So A and C are wrong. Now, is it planar or non-planar? You can check it out, sir. These are all what? If you look at boron, there's no lone pair. Boron, tuck, trigonal planar. Nitrogen, tuck, trigonal planar. All are making 3 bonds with no lone pairs. Sir, how do you know there are no lone pairs? I'll prove it to you. I'll prove you two things. Boron is in group 3, right? If it's in group 3, then it has 3 electrons in its outermost shell. 1 electron is involved here, 1 is involved here, 1 is involved here. What about the 4th one? The 4th electron is coming from the outside. So the 4th electron, when it came from the outside, it was involved here. So there are no lone pairs for boron, right? Similarly, there are no lone pairs here, there are no lone pairs here. The same idea. For nitrogen is in group 5. There are 5 electrons in its outermost shell, right? So 1 was involved here, 1 was involved here, 1 was involved here, 1 was involved here. 1 electron is still left. But what did the examiner do to that 1 electron? It removed it. So no lone pairs, nothing. No lone pair. If this was a negative charge, please always have proper concepts. If this was, for example, if this was a negative charge, then would I say it's planar? Absolutely not. Because then this would be trigonal pyramidal. Why trigonal pyramidal? Because now it is -1 and it already had 5 electrons, 4 were involved, one was left in the outermost shell, and minus means 1 more has come. So it has a lone pair and 3 bonds. Lone pair and 3 electron domains. It would look something like this then. N bonded to this B and H. So it would be like N bonded to a B, bonded to a H, and bonded to another B. And this is what it would look like right here. So then it would not be planar. But in this case, everything is planar, right? So it's not non-planar. And in fact, what is it? It's trigonal planar. And what's the bond angle? The bond angle is 120. Walk in the park, like I say. Teri yadein यार 2024 के कितने और MCQs हैं? Which row shows the correct number of covalent bonds in a molecule of methyl propene? Now, if you guys don't remember methyl propene from your O levels, I'll draw it for you. My bad of including it here, but I'll draw it for you. This is how it would look. Methyl propene. This is how methyl propene would look. Okay? I've drawn it for you in case you've forgotten O levels and IGCSE. Now, how many sigma bonds are there? Let's count it. But pretty like it's even my 6-year-old sister would do this. One, if I just told her to count the number of lines, 1, 2, 3, 4, 5, 6, 7. Why did I not count this one? This is a pi bond. In a double bond, the first is sigma, the second is pi. In a triple, the first is sigma, the second two are pi. Because after a sigma bond forms, everything is locked. Right? So we know that. How many bonds are this? 1, 2, 3, 4, 5, 6, 7. 7? 1, 2, 3, 4, 5, 6, 7. 7 right here, right? But there's one more beauty to it. You also see this one. 8. Right here. 8. And this is CH3 which I have written. What is CH3? It is a C bonded to 3 hydrogens. So it has 9, 10, 11. So in total, how many sigma bonds do you have? You don't have 8, you don't have 10, you have 11 sigma bonds. So 11 sigma bonds, right? How many pi bonds are there? Only uno, 1 pi. So 1 pi, 11 sigma. C is the correct option. This CH3, I've written it just like the examiner wrote CN for you guys. Remember? You had to open it up for yourself. Just like that, I opened up CH3. Sir, can you please share these topical MCQs? Fatma, they're still in the mix. They're not compiled completely. I'm continuously working on them. I'm making them so... See, this is the difference between me and other teachers. I'm making the topical on my own by... Somebody else is making it, obviously, but I'm circling which question should come under which chapter. And this is so important. That's why I advise you, I urge you to buy the theory booklet. I urge you to buy the theory booklet because if you work in any other booklet, way, shape, or form, it'll confuse you. Because I have designed the booklets in such a manner that are complete. I know that there's no part missing to it. Everything is connected. Part 1 is there. Part 2 is because I myself made it myself. So that's the idea. See, you guys find these MCQs so easy. But for example, if you were doing this MCQs from any other booklet, you know, which is in the market, they confuse you guys. The MCQ would pertain to chapter number 13 and they would put it in chapter number 2. And then you'd be confused like, oh, ye to itna mushkil hai, I don't even know. So this will come and this will be, probably I'll give it for free to you guys. I'll give it to those students who purchase the theory booklet. I don't get anything from the theory booklet. I'm just saying it for your sake, to be honest. I've outsourced it, but I want you guys to get it because I've put in a lot of effort on it, right? Aluminum chloride molecules at room temperature, when heated to a high temperature, AlCl3 molecules, aluminum chloride exists as Al2Cl6, which is simple molecular, okay? Simple molecular. I'm doing annotations. This should come into your brain. He's saying when you heat it, the AlCl3 molecules are formed. AlCl3 molecules are formed. So it's still simple molecular. AlCl3, but simple molecular. He's saying it's the molecules which forms, right? We also know from chapter number 4 that if AlCl3 has water, it's surrounded by water, then it becomes a hydrated ion. Aluminum bonds with 6 H2Os. Remember that? That's why I said only do MCQs when I tell you to do them. Okay, great stuff. Now I'm saying what are the arrangements of the bonding pairs of electrons around aluminum atom in the two forms of aluminum chloride? Okay, he's asking you guys the shapes for it. Is it planar, tetrahedral, whatever? Let's look at it. So Al2Cl6, you know, AlCl3 is right here and the other AlCl3 is right here. Tuck, tuck, tuck. Now, what's the beauty? The beauty is if you draw AlCl3 right here, if you draw AlCl3 right here, you know what to do. You know that there's a dative bond right here and there's a dative bond right here. So this fella, this aluminum has 4 electron domains. It has 4 electron domains. That's the electron geometry. 4 electron domains, no lone pairs. 4 electron domains, right? So 4 electron domains means what? Tetrahedral. Or 4 bonds and no electrons, right? So tetrahedral, no lone pair. So what's the bond angles? 109.5. So tetrahedral 109.5. So it's not planar. It is in fact tetrahedral, not octahedral. Tetrahedral, right? Because you look at each aluminum, each Al, right? Now, is AlCl3 planar or tetrahedral? Aluminum is in group 3. It made a bond here. It made a bond here. It made a bond here. So planar or tetrahedral or non-planar or whatever. It's planar. It's trigonal planar because no lone pairs. What's the bond angle? 120. Like a fan. Like a fan. It's not tetrahedral, therefore B is the correct option. A and D were automatically wrong at the start. Yaar, bas na. Okay, 20 MCQs. The last MCQ. Do you actually want to take a class today? I think this is enough. I'm tired. At room temperature and pressure, H2O is a liquid and H2S is a gas. What's the reason? Shabash. Without even reading the MCQ, what's the reason? Without even reading the MCQ, what's the reason? Sir, what is the hybridization in octahedral shape? Aisha, that's a good question. And it's not a part of your course, but then it's like S, P, D, a lot of this. Like, for example, if you look at SF6, if you want to know, I'll prove it in the end. If you want to know SF6, I'll do it for you, but not in your course. Not in course. Probably you learned this in university somewhere. Not in A-levels. Here, I'll teach you how you can calculate it probably. Okay, so what is the reason? The reason is hydrogen bonding. Isn't that true? So it's saying, what is the reason? O has a higher first ionization energy, has nothing to do with the being liquid or gas. The covalent bond, nothing to do with covalent bond. The significant hydrogen bonding in H2O molecules, but not between H2S. Yes, that's true. The instantaneous type, what the hell, yaar? What about, like, what in the world? What in the hell? What in the hell? And the instantaneous dipoles are stronger? Nah. The instantaneous dipoles, ID dipoles should be stronger in H2S. Why? Because sulfur has more electrons. It has more electrons. So, see, even this I can see. Oxygen has fewer electrons. If you just were to talk about the ID interactions, then ID interactions are stronger in H2S because it has more number of electrons. But we know that it is overpowered by the hydrogen bonding. It is outweighed by the hydrogen bonding in H2O. Right, so that's the idea, and we are done. 2024 set over. This is how I'm going to be doing past papers. 2024 set over officially. You've done how many papers? How many papers MCQs for chapter number 2? I'll even tell it to you. In the last MCQ chapter, how many did we do? I'll tell it to you. 2024 has 3 sessions. 3 sessions, May, June, February, March, and October, November, right? ON. I should write it as ON. I'll tell you how smart we are. May, June has how many papers, how many variants? May, June has 3 variants. 1, 3, 1, 2, 1, 1. Right? 3 variants here. 1, 3, 1, 2, 1, 1. 3 variants here. 6 and 1 variant in February, March, which is 1, 2. 7. So every year you're doing 7 papers. So you've done 7 papers worth chapter number 2 practice. That's it. That's how simple and easy chapter 2 is, chapter 1 is. Sir, I'm so excited. Class tomorrow too, please, if you're free. Do you want MCQs, Fatima? Do you want an MCQ class? Option C literally took 2 seconds. See, that's what I'm saying, Vanya. And students think that it's difficult. So just spread my name as much as possible. अब यही कह सकता हूँ. I can only say this, you know. I can only say spread my name, spread my name. Let's go. We're back. I'm so excited to be teaching A-levels. You know, I'm not even joking when I say this. I was not teaching A-levels because I did not have time. And still I don't have time. I'm literally on 3 hours of sleep, 4 hours of sleep. But it's so worth it. It's so worth it. Every moment of it is worth it teaching you guys. I swear. You know, it's not about the high number of students that I have. It's about, you know, that eureka moment. Every student's like, wow, sir, this was so easy. And this is what I love. You know, I have a smile on my face even now. Like, yeah, great. Like, where were these teachers in our time? So I don't try to, you know, boast or tell them I'm a really good teacher. But the thing is, it's all about effort. I read about 12 or 11 books to just teach you this course. I read them all over again. I had already read them before in my back in the day. But I read them. I went over my Pakistan national chemistry team stuff that I had. I went over so many things just to make sure that you guys have it very easy. You guys are actually attaining the knowledge of 11 books at this time. All the relevant knowledge of 11 books, not all. And Aisha requested the octahedral shape. We know SF6 is octahedral, right, Fatma? Now, if you want to know what would the hybridization be, I can even prove it to you. But Fatma, it's not, Aisha, whoever asked this, it's not a part of your course. For that, can you guys tell me the electronic configuration of sulfur? How many electrons does sulfur have? Just tell me the number of electrons for sulfur, please. Just tell me the number of electrons for sulfur. Can you guys tell me the number of electrons for sulfur? Or you want me to check it out? सवाल पूछ के ना फिर बताते मिलेगा. Okay, sulfur is right here. Sulfur has 16 electrons. So what is the electronic configuration of sulfur? It's 1s2 right here. 1s2, 2s2, 2p6, 3s2, 3p1, 2, 3, 4. So let's do it. 16 electrons, right? So 1s2, 2s2, 2p6, 3s2, and 3p4. Just for extra knowledge, please, none of this is a part of your course. I'm just doing it for you guys. Okay, if you want to know. This is 1s, that's 2s, that's 2p, that's 3s, that's 3p, right? So 2s, 2p, and then that's 3s, and then that's 3p4. 1, 2, 3, and 4. Done? And my question to you guys is, the highest principal quantum number of S is what? Sulfur has principal quantum number 1, principal quantum number 2, principal quantum number 3. It has 3 principal quantum numbers. Principal quantum number has S only. Principal quantum number 2 has S and P. Principal quantum number has S, P, and D. Both S, P, and D, right? Right, Aisha? If it has both S, P, and D, do you see any D here? No, I don't. Which means that D is empty. 4, 5. 3D is empty. It is there, it is there, but when we even draw electron inbox diagrams, we don't mention it if it's not being filled, right? 3D is there because it's principal quantum number 3, Aisha. So principal quantum number 3, so 3s, 3p, 3d, but 3d is empty. You have stuff here, right? Now, if SF6 forms, which is octahedral, what needs to happen is that there must be six singly filled orbitals, right? How many singly filled orbitals do you have? 1, 2 only. Okay, if I have 2 singly filled orbitals, what I can do is I can take 1 electron there and 1 electron there, right here. So now you'd see that you have 1, 2, 3. The electrons get excited just for the purpose of bond formation, right? So now this is 3s1, this is 1, 2, 3, and 1 electron has gone here, 1 electron has gone here. Are we good with 6? 1, 2, 3, 4, 5, 6. 6. What's the hybridization for it? Now the S, the P's, and the D would mix together. And what would form? You have S, P3, D2. One S combines with 3 P's and 2 D's to form sp3d2 hybrid orbitals. But is that a part of your course, Aisha? No. So in this case, the hybridization is sp3d2. But it's fun. You know, chemistry is so fun. Teach A2, please, Fatma, inshallah, sure, someday. Aisha got it, but please, sir, I tried to work it out for SF6 and I'm getting sp3d something, not sure. See, Aisha, now you're good to go. See, easy. So that's the idea. And I think we should end the class here. I'm tired. I'll also upload this onto the YouTube channel at Carboxyl Chem for you guys to just enjoy. Carboxyl Chem. So I love this. I love what I do. I still don't have time, but I swear these eureka moments, I love every bit of it.